Hello guys, welcome back to our last part of this session about inventory management. Now this is the last video again. As usually, I'm going to remind you the first, second and third part. The first was about it theory, like theoretical application of inventory management. The second, the third, and the fourth, like what we're going to do now, is only based on calculation. So the first one was the EOQ, the second was the POQ, and the third now is the discount model that we'll be doing. Now, as I said in our videos, the secret to these exercises here is only about knowing the formula, what formula to use, when to use it, and you are fine to go. So the exercise that we have here is about a company where we are given the annual demand for an item that is 10,000 units. Again, this is an annual demand, which means that is the big D. And then the cost to process an order, which is the setup cost, is 75. I forgot again to keep the rand. Okay, so it's 75 rand. And then the annual inventory holding cost is 20 per unit per year. So we have the annual cost. And then they say what is the optimal order quantity. Now, the difference with this exercise here is generally about only knowing the Q that you need to find, and then you're going to decide about the interval that you're going to use. So they hardly ask you what is it. The total cost actually is included, but they hardly ask you things like the number of orders that you need to make per year, even though you can find it. So like in this case, what we have already is like we already got our D, that is equal to 10,000. And after the D, we have the ordering cost or the setup cost that is equal to 75 rand. And then after the holding cost, after we have the holding cost that is equal to 20 rand, like this. So these ones here are the, how do you call them? These one here are the main information for this part here. So I'm gonna put them here, and then after an easy way to solve this exercise is generally by doing it with a table. And then when you do it with a table, we can still take the same table here, but we are going to add more other values like the setup cost, like annual setup cost, obviously. So yeah, let me keep this table here like this, and then yeah. So we are going to add another range that we're going to call we're going to add another cell that we're going to call the range. So the quantity that we have here is going to tell us we're going to solve it based on the range that we have. So we'll do something like this. So we move this and we put something like range. So we have the range 1 that goes from 1 to 99 units, range 2 from 100 to 999, the third one from 1000 to 499, and the fourth one from 5000 and more. So what they mean is like if you buy a product that goes from 199, you need to pay 250 rand per unit. And if you buy a product that you buy something, you buy a 100, the number of units that vary between 100 and 999, you need to pay 2.35. And if you need to buy 1000 and more, you need to pay 2.10 rand. And if you're buying 5000 and more, you pay 1.85. Now this is the data that you already got from the problem. So they want us to calculate how am I going to call it? They want us to calculate Q. So one way to calculate Q is first of all we need to find we'll find the annual holding cost and the annual setup cost, and then from there we're going to find the total cost, because we need to know which interval is the best. So now from here, the first thing that we're going to do is like we're going to find a cell whereby we'll find only what Q, and after finding Q, we'll find the annual I'll put like H, which is holding cost, and then after we are going to find the annual S cost, which is the setup cost, and finally we are going to also find the PD. Remember, in one of our formula when we were doing the video here, I was saying that we had, for the discount model, the total cost include the PD. This is the formula that we'll mainly use for this one here. So my page is doing here. Let me do it let me solve it like that. Yeah. So I hope you will be able to see the the calculation here. So we'll find the cell for the PD, and after the cell for the PD, we'll find the total cost. Now, the total cost will be the sum of the annual holding cost, the annual setup cost, and the PD, which is even the formula that we used here. So first thing first is to find the Q. So we need to find the Q for the first range, Q for the second range, Q for the third range, fourth, and so on. So what I'm going to do is like I'll put a Q here with an index of 1, saying that this one is a Q for range 1. So it's gonna be Q1 here, like this. I'm sorry for the size because I need to make sure that everything fits on the page. So this is the Q. Again, the formula that we're going to use for Q is a simple formula that we use for the EOQ. So that formula says that Q must be the square root of 2ds divided by h. So this is, let me insert the formula first. The reason why I'm putting the formula is for you to know what we're doing and where we're going. So the formula is 2d multiplied by s, and then we divide everything by h. So I'm going to zoom in only on that part there. So this is the formula that we're going to use for Q1. Now, I want you to realize something. You will find out that whenever we are working, because h is the same, that means we're going to use the same formula for Q1, Q2, and so on. And we are going to have the same constant, which means there's not really a point to find different values of Q. So the Q that we are going to find is going to be the same, either Q1, Q2, and so on. So from here, if we keep the same formula here and then we replace the values, we get 2ds like this. So the value of D is 10,000. And the value of S is 75,000. And then we have a value of H, which is 20 rand. So we need to replace everything into our calculator, which gives us 2 multiplied by D, which is 10,000. I wrote 1,000, sorry. Then we have 10,000 here times 75, that we divide by 20. Now the value that we get is approximately 273,86. So this is the value of Q. Remember, it's the number of units that we can say it is approximately 274 units. Now, this is the value of Q. Imagine if we had to find Q2. Obviously, we'll have a 2, we'll have a D, which is 10,000, an S that is already 75, and an H that is 20. So that means even if we had to work Q2, we realize that it will be a copy and paste of Q1. So Q2 is going to be the same as Q1. Obviously, we can say that. Now we can say Q1 here. Q1 will be equal to Q2, will be equal to Q3, and it will be equal again to Q4. That means there's no even point to find it. Now, we are going to replace that value of Q in this table here, but we are not really going to use the same value of Q. What we're going to do is like we're going to adjust it. Now this is the difficult part about this chapter here. By adjusting it, what you're going to do is, we know that the first value of Q, or this value of Q, is 273. Now if Q falls in the interval, we are going to keep it. If it falls below the interval, we are going to adjust it to the lowest, how do we call it, the lowest boundary of the interval. And if it falls outside, like it's above the inventory, above the range, we'll reject it. Now in this case, we have a Q of 274. Let's say Q1 here, based on our calculation, Q100 is 273. But this range here must go from 1 to 99. So this is just a bracket that I'm opening. So we have 100 all the way to 99. So that means the value that we have, our value of 273 is here. But our range goes from this one to this one here, like this. So that means because, what I'm going to do, let me put it like this. Yeah. So this is our range. Now, because the 273 fall outside of our range here, and it's above, so it's not part of the first range anymore. Now the second range is going from 100 to all the way to 999. Yeah. So what I'm going to do is I'm going to draw all the range, and then we will see. I think this one will be a better way for you to understand. So yeah, like this. And then after we have 1000 here, that goes all the way to, let me even remove the 273. So we have 1000 that go to 499 here, which is our third range. Let me give it another color, yellow. And then what have I done? Here, let's remove no color. And then what is happening? So we have the third interval, one, we have the first 199, the second is this one, the fourth. So the fourth, it goes from 1000 or more. So this is the third interval. So we are going to check the value that we have. Let me put it green. So we have a Q that is equal to 274. Obviously, 274 is somewhere here. That's why we have our value of 273 or 74,86, like this. So this is our value here. Let me highlight it in red, or let me put it in red. Yeah. So that means that this is our value. Obviously, it's not falling in the first interval. It's way above the first interval. So what you're going to do is, like, we are going to reject this range here. It's not good. We are not going to calculate anything from it. So we put X, meaning it's cancelled. Now we look at the second interval. The Q that we have is below the 273. Falls inside the range from 100 to 999. That means we'll keep the same value of Q, which is 273,86, because it falls in this range here. Now let me even put it like this. Let me cancel first, no colors, and then yeah. So what you have here is, what am I doing? So we start from here, which is normal. So this one is, we're going to call it range 1, and range 2 start here, and then here we have range 3, and here we have range 4. So you realize that in range 1, the 273 doesn't fall. It's above range 1 because in range 1 is so big. That's why we cancel. But it's inside range 2 because range 2 goes from 100 to 999. And when you look at range 3 now, it starts from 1000 to 499. That means it's below 1000. Because it's below 1000, we're going to adjust it to the nearest, the lowest boundary of the third range, which is 1000. So we're going to keep 1000 here. And then because it's also below the 5,000, it's way below it, so we're going to keep the lowest boundary of 5,000. Now, if whatever we add, let's say it was, for example, 500, or we got a Q2, a Q3 of 500, it should be not 500, let's keep 3,000. 3,000 should be here. That means in range 3, we are going to choose that value here. And then this is the one that we will put here. Instead of 1000, we will put 3000. And if we have a value of 600, it will be in the fourth range, and we are going to keep the 6000 here. So this was just a bracket, so that means whatever we have here doesn't apply, even the 3000 doesn't exist. So this is our exercise here. So we are going to calculate only for range 1, 2, and 3. Now what we're going to do is to calculate first of all the annual holding cost for the first range, the second, for the second, the third, and the fourth, the annual cost for the second, the third, and the fourth, and then the PD. Now this is what we're going to do. So whatever calculation we are going to do here, we're going to start it from, so we calculate first of all the annual holding cost. So you're going to calculate for all of them. So you have the annual holding cost. This one I'm going to put 2, just to remind you that the annual holding cost for the second range. And the formula for the annual holding cost is easy. The Q divided by 2 times H. Now times H. So in our value here, we got a Q that is already given, that we found, of 273. So we got 273 86 that you are going to divide by 2. Let me put everything into my bracket, and then we multiply by h, which is the value of h that is given here, which is 20. So we have 273,86 divided by 2, and then we multiply by 20. So the value that we get is 2. Remember, it's in rand. It's 273,8,6. So this is the annual cost as far as interval 2 is concerned. So we need to do the same thing for the third range. Now here is the holding cost for range 3, and we're gonna find out something also for range 4. Now in this case, Q, remember that the value of Q is not the same anymore. The value of Q based on the third range is 1000. So on top here, what is going to change is only the 1000, and here what is going to change is the 5000, because that is the value of Q. So we have 5000 like this. So we take 100, the value is going to change to. So we have 1000 divided by 2, which is 500 times 20, we get also 10,000. So here the value that we get is 10,000, it doesn't change. And then here we have 5,000 that we divide by 2.5 times 3, and then we get 5,000 again. So whatever we have here is the range. So we have the annual cost, which is here, which is 273,8,6. And then here we have 10,000. And then the last one gives us 5. Sorry, I did that was 50,000. Yeah, we got 50,000 here. So what we're going to do next is to find the annual setup cost. Now the annual setup, remember that whatever we got here was an annual cost. That was the annual holding cost. So we are going to find the annual holding cost with another formula. So this one here is the annual S cost for 2. The annual S cost formula is D times S, and then we divide everything by 2. Unless I'm mistaken, let me check it again. Yeah, D times S divided by Q. Sorry, D times S divided by Q. Yeah, so for S2, we have our value of D. The value of D is 1000. So we have, is it 1000 or 10,000? Let me check. So it's 10,000. Yeah. So we have D of 10,000, and we have our setup cost of, what is the setup cost of 75? Like this, and then we divide by Q. Now the value of Q depend also on the interval. Now in this case, the value is 273, like this, and then you're going to get a value. So I'm going to copy and paste the same formula again so that we will find everything quickly. So we have this, but what is going to change is D is still the same. Q, we multiply by S and we divide by Q. The value of Q for the, now this one is 3 because it's, this one is 3, DSQ, and then the value of Q here is 10,000. We are taking the Q from the second, the third range here, and then we do the same thing for the fourth interval. We have a value of D that is already given, that is 10,000, S is 75, and the value of Q is 5,000. So we get our 5,000. So what is left is just replace everything. We have 10,000 times 75, which gives us 75, which gives us 750,000. That we're going to divide by 27386, which gives us 2738,63. So this is what we get is around here, and then we get the 750,000 that we divide by 1000 here, which gives us 750 in this case here. And the last one is the same value, but we divide by 5,000, which gives us 150. So 150, yeah. So those are the three values that we already have here. So we find what's annual cost here. So the annual cost, let me give it, I'm gonna give it another color later. So the annual cost here, we start from 2, which is this, the 27. Again, you realize that the value that we have is approximately the same as what we were. So the annual setup cost for the second range is almost the same as the annual holding cost. But you realize that it's not really the same for range 3 and 4, because range 3 here we got 750, range 4 we got 150. So this the gap is a bit too huge. But anyways, let me just check again. My calculation is D times S divided by Q. D is 10,000, then about 75 divided by the value of Q, which is 5,000. Yeah, which is normal, fine. So we get a value of 150. And then what needs to be done next is to calculate the PD. So to find the PD means price times the demand. Now the price is already given here. Based on this interval, they say that the price is 250. So that means, let me put it like this. So we're gonna have PD for this one here. No, it's not the same. So we're gonna get the PD for range 2, and then we'll do it for the rest. So the PD is the price times the demand. Now the price for range 2, we are in this range here. The price is 2.35 times the demand. The demand is already given, which is the big D, which is 10,000. Get something like this. And then we're going to solve the same thing for PD for the third interval and the fourth interval. So we get 3 here and we get 4 here. Now, in this case, what we get is for the second interval, we had 2.35. That means for the third interval is 2.10 that we're going to replace here. And the fourth interval is 1.85. 1.85. So this is how you find the P for the interval. So 2.35 times 10,000 gives you 23,500. It's in terms of rand here. And we do the same thing, 2.10 multiplied by 10,000, which gives you 21,000. And then we have 185 that we multiply by 10,000, which gives us 18,500. So this is what we get now. We got the 3PD. The first one is 23,500. The second one is 21,000. And the third one is 18,500. So these are the three costs that we already got here. So finally, what is left is only to take this cost here, we add them to get a total cost. So the total cost is going to be, you know the formula already, so there's no point for me to write it down. So the total cost is going to be the sum of these three values here. This will be the total cost for range 2. So it's 2738,6 plus 2738,63 plus 23,500. So the cost that we get here is going to be 28,977,23. This is the total cost for range 2. Total cost for range 3 is going to be the three values here, which is 10,000 plus 750 plus 21,000. And we get a value here of 31,750. Yeah. And finally, we have a total cost that we need to find for range 4, which is 50,000 plus 150 plus 18,500, which gives us 68,000. Now, based on 68,650, yeah. Now, based on the values that we have here, we need to calculate. We're gonna choose the total cost that is the lowest between that is the lowest cost. I mean, we're gonna choose the range of the lowest total cost. So the range of the total cost is this one here, which is range 2. You realize that we have 28,000 here, that is lower than 31,000, that is also lower than 68,000. So that means range 2 is going to be the best range that the company is going to choose. Why? Because it has the lowest cost here. It has the lowest cost, and then the company will only have to pay 2.35 rent per unit, and they'll have to order 273 units. So it's gonna save more. Remember, the objective is always to maximize costs, and we also need, I'm sorry, it maximize profit. So we maximize profit, and then we minimize cost. So every time that you maximize profit, you know that you minimize cost. And once it's done, you realize that you have done your job as an operation manager. So in this case here, the solution, because the question was about find, they say that what is the optimal order quantity, which you already find, it was 273, which is the Q. Now, given the following price break and so on. So given the following price break, Q is going to be 273 with a price of 2.85 with an annual cost of this, and that on the PD, and this is the total cost. In fact, this is how you calculate the discount model. Again, thank you so much for your time. I really hope that this video was helpful, and please comment whenever you don't understand anything, or if I made a mistake somehow, let me know so that we can rectify everything in the comment section. Besides, I'm going to upload now this document here in my on my channel so that you can also have access to it and go through it step by step. So thank you so much for your time. Again, I really hope that this video was helpful, and this is the last video of this session about inventory management. So thank you so much for your time, and enjoy the rest of your day. See you next time.